So last time we talked about images, JPEGs and vectors and the difference between them, and we got a little bit into bit depth, types of those images, and how you would work out the size of an image. Okay, so we also talked a little bit about compression, and we briefly talked about the difference between lossy and lossless compression. But I'm going to go into a little bit more detail here. Now, this isn't explicitly in the syllabus as far as I can see looking through it quickly, but I swear there have been questions about this in the past. And even if there's not, it's a really good background information to have to add more detail to your answers. So, two types of compression. So, when we want to make an image smaller or when we want to make a file smaller, we can do it in a way that's lossless or lossy. Now, lossless means you don't lose any information and you can always get it back. So you can take your image back to that original size, or you can take your picture back to that original, well, an image and picture, you can take your file back to that original size without any problems with it. You have no loss, you lose less, it is lossless, okay? The other type is lossy compression, so that's where you lose stuff. So you make the file smaller by taking image data out of the image or file, and you just get rid of it. You throw it out. Now, lossy compression, why would you ever use that if you can't go back? Well, lossy compression allows you to create a much smaller file size, and also you might decide that you never need that original file back again. And if you never need it back again, what's the point of, compressing it in a way that might make it harder for people to view? So, an example of, let's start with lossy compression. The one that you probably know most about is the JPEG. So, we talked in the previous episode how JPEGs work, but JPEG is used pretty much all over the internet for image files to make those image files smaller so people with slower connections can view them more easily. Now, we've decided, well, whoever it is in power has decided that the internet doesn't really need high quality images, and most of us agree. We would much prefer for the page to load quickly than to have amazing quality images that we can take and edit and blow up and do whatever we need to do with. We just don't need it. So what we do is we take our original image, and most images taken with cameras are pretty high quality these days, and then we look at the actual image and we look at the similar colors, and where it's similar, we create an approximate value, and then we toss out all of the extra information. We can never get it back. So streaming media uses lossy compression. So when you watch a YouTube video, it's usually compressed. The sound is compressed, the video is compressed, so you might notice that sometimes it's, the sound especially can be quite low quality on our online videos. We've decided to compress it down. You can create artifacts with this. So an artifact is weird things that shouldn't exist from the compression. So sometimes you might get some weird imagery that comes up. A good example of this is when you compress a GIF. So a GIF can only show, I think it's 256 colors at a time. Don't quote me on that, but let's just say it can show 256 colors at a time for just a very good user, right? If there's more than that in there, it's going to approximate the colors. You might get some weird shading that doesn't look right showing up on that. It's gone though. You never get it back with that GIF if you've compressed it. We throw out information. The color data is averaged out. So to do that, we use something called quantization. So we approximate. So, I mean, we can overcomplicate it, but we just see, yes, this red is close enough to this other red, so we're just going to make them the same red, okay? What lossless compression does is it packs everything close together. So let's say, for example, we had, I'm just going to give you an analogy. So we had a string of data that was B, 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 C, 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 B, W, B, B. So it doesn't matter what those are. But when we losslessly compress something, the computer would say there were 4 Bs there at the start. So I'm going to go 4B. Then there were 3 Cs. So 3C, B, W, because those were single, and then 2B. So instead of having, what do we have here? We've got 7, 8, 9, 10, 11. Instead of having 11 colors in a row, which takes up 11 units of data, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've compressed it with numbers. Now, can we view that image in the same editing program? Maybe not. So what we've got to do then is we've got to uncompress that image. So we have to unzip it if you use the zip file, and then we can view it in the original image again. So sometimes lossless compression may not be viewable in the same programs that you used before. Sometimes it does. But you know that some files can use lossy compression, some files can use lossless, some files can use a combination of both. So example, PNGs do not compress, they use lossless compression. The idea is that you can get back to that original file size for them. But a TIFF might use both. A JPEG always uses lossy. The main thing that you have to take away and learn from this though is that with lossy compression, it's a smaller file size, but you can never go back. With lossless, you can always go back to that original file. They both have their pluses, they both have their negatives, all right? That's what you would probably write about in your HSC question. So when you talk about which one should be used and which one shouldn't be used, you need to have those things in mind. I'll move on to the next section of the syllabus now for images. We're still on page 43 and we're going to talk about importing images. So importing images is how you get images into your computer. Obviously a computer is just a binary machine that works with ones and zeros, so how do we get an image to show up on screen? And how do we get things in the first place? So we can talk about clip art. So clip art are pre-made images that you would find on the internet, or you might even find inside a Microsoft Office program if you lived in the 90s. It's hard to talk about them because we don't really use clip art anymore. It's been replaced by stock images for the most part. But what clip art used to be was it had to be illustrated. First off, it couldn't be a picture. It was usually quite simplified, and they were used a lot by people like me personally in the early 2000s when we were creating primary school projects, okay? You don't really see them very much anymore, and they're kind of a little bit daggy, but yeah, I don't really know why I'm talking about them for so long, but clip art is that kind of pictograms and pre-made sort of icons that you would find that you can put into any sort of file. You see them all. Older people tend to love them, okay? I'm going to move on. I'm going to move on to the next element, which is screen capture. So you can actually use QuickTime on Mac, you can use Adobe Captivate, a number of other programs to capture what you are doing on screen. Once you've captured it on screen, you can then take that imagery and move it into another application where you can edit it, do that sort of thing. Take a screenshot is another element of screen capture, and we can go from there and get the imagery into the computer through that. Moving on to the next one, we've got scanning. So a scanner is effectively a light sensor, much like a camera is a sensor for light, but it works on a flatbed, shines light which bounces onto a piece of paper. Where the light bounces off, the sensor takes that information, translates it into binary, which is then sent through whatever cable setup you have for your computer, and then that will obviously show up on screen as an image or text or whatever you've got your scanner set up to do. Then we've got a graphics tablet. So a graphics tablet is basically a pressure sensitive sensor. So rather than working with light like a scanner, you might have a tablet idea on the ground or on your table, and then you've got a pen which sends an electrical signal when they get close to each other at varying angles depending on the complexity of your graphics tablet. That is then translated into, well, we've got our pressure, but also our coordinates X and Y on this 2D shape, which then manifests itself in a binary signal which goes into the computer and is represented in a drawing program. So that's a way to approximate the idea of a pencil on paper digitally. Graphics tablet. We've got a camera, so a camera is merely a light sensor. These days we don't use film, although you could talk about film, but once you've got film, you've got to scan that film in. So then is it the scanner that's creating the image? Debatable. But a digital camera takes light going into a sensor, then it takes that imagery, converts it to data, which is then sent across there. So what is the difference between a still and a video camera? Not much. The only difference with a digital still and video camera is a still camera takes a single frame of information, whereas a video takes a number of frames per second based on whatever you set the camera up to do and whatever the camera is capable of. So if a camera is shooting at 30 FPS, that's 30 frames per second, which means it's taking 30 little videos a second. That's all it is. That's all video is. It's just a bunch of frames, one after the other. Finally, we've got image libraries. So image libraries and stock photographs, they're essentially the same thing. An image library could be offline though, whereas most stock photographs you would get online. Look. You know what a stock photograph is at this point. There's no point in me even talking about it. Basically, they're usually paid. They often are very specific and strange in what they're showing, but also quite mundane. You can pay for their use. They're available in different resolutions. Usually, maybe you pay a little bit more if it's higher resolution. If you don't pay for your stock images, usually they have a watermark over the top, so it might say the company in like nearly transparent text over it, so that's a good way to see if somebody's paying for their stock images or not. Stock images are useful to the average designer, but they do have a look about them. They have a very corporate look. It is very easy to tell if something is a stock photograph or if it's not. Let's move on from there. Let's talk about, the other image that you might have is you might like use text to create an image. Like you might create a picture of a cat out of like brackets and speech marks and things. I mean, like you could talk about that, but let's just move on. So if we move on to page 44 of your syllabus, you've got to talk about object layering. So object layering is basically where you use text and images and place them on top of each other. You've done it in Photoshop, you've done it in Illustrator. It's basically the combination of those things together, and that's a good way of creating images. Okay, so let's move on to the next part of the syllabus, which is image enhancements. So filters are things that are put over the top of an image to change it in some way. So in Photoshop, we're talking about things like adjustment layers. If we're talking about analog photography, we're talking about actual filters that you could put over the lens. So those little things clipped over the lens, it might have been colored plastic, and that's obviously going to change the way that the photograph comes out. Okay, so an example of filters would be on a program, an app like Instagram. You can add sort of a filter which makes everything look brown or brighter, or make everything brown sepia. You can up the contrast of things, and what those do is it kind of just changes the way that an image looks for whatever purpose you have for it. I don't really care, but those filters can do things like help with exposure if you've underexposed your photos. So you could put some gamma correction filter on it, which would make the light more sensitive and all sorts of stuff like that. There's plenty of different ways to do it. Photoshop obviously has inbuilt filters. Instagram has inbuilt filters. Photoshop's are a little bit more complex, and you can do that adjustment layer thing where it affects every layer below it, but not everything above it, whereas something like an Instagram filter is basically a top layer and everything underneath is done. Okay, let's move on to special effects. Now you have an idea of what a special effect is already because you've lived post 2000. And special effects are divided into the categories of optical effects and mechanical effects. So there is a definite distinction between special effects and visual effects, but for the purpose of this syllabus, we're going to do them both together, okay? So special effects are really these days known as practical effects if we're talking about it in terms of official naming for stuff. So an optical effect is sort of an optical illusion sort of thing. A mechanical effect is something where you have like a giant robot or something burst out of something that happens in real life, okay? But special effects, we're talking about things like CGI. It gives filmmakers greater control, but it needs to be used within reason. So if we look at, I don't know, Star Wars. If we look at the Star Wars prequels, they had a huge issue where they just fully lent into CGI. They did pretty okay because they spent a lot of money on the special effects, but 10, 15 years from now, if they don't remaster it, it's probably going to look like garbage. And we can see that, especially in some low-budget CGI movies from, like 10 years ago. So an example that springs to mind is The Scorpion King starring The Rock. So if you look at some of the CGI in that, it's just bad now. Whereas practical effects kind of have stood the test of time a little bit better. We're seeing more and more that we're moving towards those more practical effects, but if we're talking about graphics and special effects, we're really talking more about, I don't know, like liquefy and horrible things like that, that you can use in Photoshop to make like eyes bug out and do all of that sort of stuff, okay? If you're talking about special effects, usually in the HSC they're going to ask you about video. It just kind of works better for that. There's another point here called anti-aliasing, okay? So when you're working with images, anti-aliasing is when you get rid of these little jagged edges on things by arbitrarily smoothing them out. So if you have a graphics card, you can anti-alias and smooth out those images to create an image that's more pleasing to the eye, because there is a weird distortion that comes when objects get made really small, especially if you're working with sort of polygons and 3D shapes and stuff. It just doesn't work when things get small and further away. So we put in like a blurring sort of effect in 3D games anyway to make everything look smooth. And a good example of that is digital type. So if we move back to the idea about that we talked about in the very first episode that I filmed, when you use a lower resolution screen and you've got fonts, it can have jagged edges on like the letters that we're working with there. So when we anti-alias something, we remove those jaggies, for want of a better word. So these are those step-like lines. Because remember, every image that's on a computer screen needs to be made up of pixels. So no matter how high quality your image is, you're still going to have that pixelation. And especially when you get down to a small point size, and especially on an older computer screen, that's going to be really noticeable. So what anti-aliasing does is it kind of blurs those distinct steps. And what that does is it tricks our eyes into thinking something that's smooth. So what we do is we've got our steps. So our defined steps when you get close to something. You've got a straight line. When you do a diagonal, it needs to do a step. What anti-aliasing does is it introduces, in between that step, it has grey. So say you've got a black line. You've got a black line and it's a curve. Now we can't show a true curve on a computer screen. We have to do steps. That's just the way it is, all right? Because we're working with pixels which are square in nature. Always remember that. But if we put in grey on the edges of those steps, our eyes get tricked into thinking that it's a curve. We smooth it out. We anti-alias it. That's something that you want to think about, okay? you might get asked what anti-aliasing is in a multiple choice question or a short answer question, or you might get asked, what is a way that we could reduce jagged edges or pixelation in an image? So we could anti-alias it, and that would help. That would be a pretty hard question though. That would be one of the questions that is meant to like separate the band 5s from the band 6s. So hopefully you don't get that one, but it could. The final thing we're going to talk about today is image manipulation. Now this is pretty quick. The things I have to talk about are stretching, skewing, rotation, and color adjustment. So when you stretch an image, you're taking your original image and you're kind of pulling it in a direction. So you might take a picture of someone's face, stretch it out so they look extra wide or extra tall, kind of like a funhouse mirror sort of effect. When you skew something, it's kind of rotating it or kind of pushing it in a direction. So rather than going like there, or stretching it this way, you're kind of smushing it. It's hard to explain, but visually, if you see an image that's been skewed, you kind of understand. It can be used in photoshopping. Say you've got a picture of a billboard that's not flat on and you want to put your image so it looks like it's placed on that billboard. You could skew your image sideways, you could change the perspective of it through that, and then it would work. Rotation of an image is about rotating the image. So if I'm starting like this, if I rotated 90 degrees, my head would be this way and my body would be that way. If I rotated 180 degrees, I'd be upside down. Okay, color adjustment is literally adjusting the color. So you can do the hue in Photoshop by doing Command or Control U, and then you can change the value of the colors. It will adjust the color, it'll make everything a different color. Fancy that. Look, that sort of stuff is pretty easy. It usually shows up in the multiple choice, maybe short answer, you'll do fine. Just as long as you understand from this lesson the difference between lossy and lossless compression, you should be doing fine, okay? Alright, thank you for watching this episode.